Next point we are going to see chemical properties of benzene. Now here these benzene generally undergo substitution reaction, but they do not easily undergo addition reaction or oxidation reaction. But in special cases or in specific condition, this benzene can undergo addition reaction. In which first we are going to see addition reactions of benzene, in which first reaction is addition of chlorine. Now this is benzene, C6H6. When this benzene is treated with chlorine molecule, 3 molecules of chlorine are used, and this reaction is carried out in presence of ultraviolet rays or in presence of diffuse sunlight. Then addition of these 3 chlorine molecule takes place across the double bond of this benzene to form benzene hexachloride like this. Now here hydrogen, here chlorine, here hydrogen, here chlorine, then hydrogen, chlorine, hydrogen, chlorine, hydrogen, chlorine, hydrogen and chlorine. This is C6H6Cl6. This is benzene hexachloride. This is benzene hexachloride, and this gamma isomer of this benzene hexachloride is called as gamma hexane, and or it is also named as linden, and this is very useful insecticide. That is, this gamma isomer of benzene hexachloride is used as an insecticide. Second addition reaction we are going to see is addition of hydrogen. Now here, when benzene is heated in presence of nickel catalyst at 453 Kelvin to 473 Kelvin, then here 3 molecules of hydrogen get added across the double bond of this benzene to form cyclohexane. Addition of 3 molecules of hydrogen takes place. This reaction is also known as hydrogenation of benzene or reduction of benzene to form cyclohexane. Now here molecular formula of benzene is C6H6 and this is cyclohexane. This molecular formula of cyclohexane is C6H12. In this way, when benzene undergo hydrogenation in presence of nickel catalyst at higher temperature, that is 453 Kelvin to 473 Kelvin temperature, gives cyclohexane. Now third reaction we are going to see is ozonolysis of benzene or reaction of ozone with benzene or addition of ozone. Now here, when benzene is treated with ozone in presence of inert solvent like carbon tetrachloride, then addition of these 3 molecules of ozone takes place across the triple bond of this benzene and formation of benzene ozonoid takes place like this. Now here there are 6 carbon atoms, 1, 2, 3, 4, 5 and 6. Now where there is double bond, there is addition of O3 takes place like this. O, 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 O. Then here there is single bond. Again addition of ozone takes place. Then again. This is benzene triozonide. This is benzene triozonide is formed, and when this benzene triozonide undergo decomposition in presence of zinc and H2O, then here 3 molecules of H2O are used, and here breaking of this bond takes place like this. and here breaking of this bond also takes place to form carbon oxygen double bond here. Same thing happened here. To form 3 molecules of glyaxal. Now here there are hydrogen atom. Formation of 3 molecules of glyaxal like this. Plus ZNO. 3 molecules of ZNO are formed. This is glyaxal. Glyaxal formation takes place. In this way, benzene undergo ozonolysis in presence of inert solvent like carbon tetrachloride. Addition of 3 molecules of ozone takes place across the double bond of this benzene to form benzene triozonide, and this benzene triozonide when undergo decomposition in presence of zinc, formation of 3 molecules of glyaxal takes place. Now we are going to see substitution reactions of benzene. Now here benzene easily undergo electrophilic substitution reaction. Here benzene undergo halogenation, nitration, sulfonation, acylation, alkylation, etc. type of substitution reaction. Now we are going to see first reaction, halogenation of benzene. Now here in halogenation, when one hydrogen atom from benzene ring is replaced by a halogen atom, then it is called as halogenation of benzene. Here first we are going to see chlorination. Chlorination of benzene. When benzene is treated with chlorine molecule in presence of anhydrous AlCl3 or anhydrous FeCl3 or in presence of iron in dark, then here electrophilic substitution of this chlorine takes place and one hydrogen atom from benzene is replaced by halogen atom or chlorine atom to form chlorobenzene like this plus HCl. This is chlorobenzene. Now here electrophile is chlorine or it is chloronium ion. How it is formed? When this chlorine molecule is treated with this anhydrous FeCl3, then here breaking of this FeCl3 is a electrophile and therefore it attracts this chlorine minus ion or this nucleophile towards itself, and this chlorine takes away both bonded electron pair with this to form FeCl4 minus ion, and this chlorine becomes positively charged. It is called as chloronium ion, and this chloronium ion or this electrophile is replaced by this hydrogen atom to form chlorobenzene. In this way, chlorination or chlorination is carried out. Now we are going to see bromination. Now here also this Br2 is treated with FeBr3. This is electrophile. Now here breaking of this Br bond takes place. This Br take away this both bonded electron with itself to form FeBr4 minus and Br plus. This Br plus is act as an electrophile. Here substitution reaction takes place in presence of this FeBr3 in dark. Then here substitution of this hydrogen atom takes place by this Br plus to form bromobenzene. Br plus here HBr. This is the bromobenzene. In this way, chlorination and bromination of benzene is carried out to form chlorobenzene and bromobenzene respectively. But iodination of benzene is not possible. It is a reversible reaction. When benzene undergo iodination, formation of iodobenzene and hydrogen iodide takes place. This hydrogen iodide is a strong reducing agent which reduces iodobenzene back into the benzene, and therefore this reaction is a reversible reaction, and therefore iodination of benzene is not possible. Now we are going to see next reaction. When this chlorination of benzene is carried out in presence of excess of chlorine molecule, that is, if 6 numbers of chlorine molecule are used, then here formation of hexachlorobenzene takes place. That is, all hydrogen atom from benzene are replaced by chlorine atom, 6 chlorine atom, to form hexachlorobenzene plus 6 HCl. In this way, when chlorination of benzene is carried out in presence of excess of chlorine molecule, then formation of hexachlorobenzene takes place. All the hydrogen atom from benzene are replaced by all 6 chlorine atoms. Second substitution reaction we are going to see is nitration. Now here, when benzene, this is benzene, when it is treated with nitrating mixture, that is mixture of concentrated nitric acid, that is HNO3, and concentrated sulfuric acid. HNO3 is the nitric acid and H2SO4 is the sulfuric acid. This is concentrated and this is also concentrated. When mixture of these two, it is called as nitrating mixture. And when benzene is heated with nitrating mixture at 313 Kelvin to 333 Kelvin temperature, then here substitution of this hydrogen atom takes place by this NO2 group. That is, hydrogen atom from benzene ring is substituted by NO2 group to form nitrobenzene plus H2O. This is nitrobenzene. Formation of nitrobenzene takes place. Now this is electrophilic substitution reaction. Here reaction between nitric acid and sulfuric acid is carried out. This is HNO3, that is nitric acid, and this is H2SO4. Then when reaction is carried out, here formation of 2 moles of HSO4 minus, 2HSO4 minus plus H3O plus NO2 plus. Now this NO2 plus acts as an electrophile, and this electrophile is substituted by this hydrogen atom of benzene ring to form nitrobenzene. In this way, benzene is converted into nitrobenzene by using the nitrating mixture at 313 Kelvin to 333 Kelvin temperature. Now we are going to sulfonate. Now we are going to see the sulfonation of benzene. Now here, when one hydrogen atom from benzene is replaced by SO3H group, then it is called as sulfonation of benzene. When benzene is treated with fuming sulfuric acid, or when benzene is heated with fuming sulfuric acid at 373 Kelvin temperature, then here this hydrogen atom from benzene is substituted by this SO3H group. Here formation of benzene sulfonic acid takes place plus H2O. This is benzene sulfonic acid. This fuming H2SO4 is also called as oleum. Now here, when these two molecules of H2SO4 or fuming sulfuric acid they forms H3O plus ion plus HSO4 minus ion plus SO3H positive. That is, this SO3H group is electrophile, which is electron deficient species, and this SO3H group is substituted by the hydrogen atom of benzene ring to form benzene sulfonic acid. In this way, when benzene is treated with or heated with fuming sulfuric acid, gives benzene sulfonic acid. Now next substitution reaction we are going to see is Friedel-Crafts alkylation. Now in alkylation or in Friedel-Crafts alkylation reaction, one hydrogen atom from benzene is replaced by any alkyl group, that is R group. That is, one hydrogen atom from benzene ring is replaced by alkyl group, then it is called as alkylation of benzene. Now here, when this benzene is treated with alkyl halide like methyl chloride, this is methyl chloride, in presence of anhydrous aluminum chloride, anhydrous AlCl3. Now here, this methyl chloride or alkyl halide, this is alkyl halide, when this alkyl halide react with this anhydrous AlCl3, then this chlorine is more electronegative, which takes away both bonded electron with itself and get attracted towards this electrophile, that is AlCl3, to form AlCl4 minus and R plus. This R is an electrophile. This acts as a electrophile. Now here, one hydrogen atom from this benzene ring is replaced by this methyl group to remove HCl, and here formation of toluene takes place. That is, when benzene is treated with methyl chloride, then here formation of methyl benzene or toluene takes place. This is toluene. This is the alkylation of benzene, and this reaction is named as Friedel-Crafts alkylation. Next reaction we are going to see Friedel-Crafts acylation. Now here, when benzene is treated with acetyl chloride or acyl chloride, that is RCOCl, then one hydrogen atom from benzene ring is replaced by COR group. This reaction is named as Friedel-Crafts acylation reaction, in which one hydrogen atom of benzene is replaced by RCO group or acyl group. This is acyl group. Now here, when this benzene is treated with this acetyl chloride, this is acetyl chloride, in presence of anhydrous AlCl3, that is aluminum chloride, then here this hydrogen atom from benzene is replaced by COCH3 group to form acetophenone like this. This is a ketone, COCH3 plus HCl. This compound is acetophenone. Now here, this COCH3 group acts as an electrophile. Now this is acyl chloride and this is aluminum chloride. When reaction between this anhydrous aluminum chloride and acyl chloride takes place, this chlorine get attached to this AlCl3 to form AlCl4 minus plus here RCO plus. This acyl group acts as a electrophile, and electrophilic substitution takes place. One hydrogen atom from benzene is replaced by this acetyl group to form acetophenone. Now here the acetylation of benzene is also carried out by using acetic anhydride. Now the structure of acetic anhydride is like this: CH3, CO, O, CO, CH3. This is acetic anhydride. And when this acetic anhydride is treated with benzene in presence of anhydrous AlCl3, then here hydrogen atom from benzene is replaced by this COCH3 group to form acetophenone. This is acetophenone plus CH3COOH. Acetic acid is formed. That is, acetylation of benzene is also carried out by using acetic anhydride. In this way, acetylation of benzene is carried out by using acetyl chloride and acetic anhydride. In this reaction or in acetylation reaction, one hydrogen atom of benzene is replaced by COR or acyl group to form corresponding aromatic ketone. Last substitution reaction of benzene is combustion. Now here, when benzene is burned in air, then here, now this is air, formation of carbon dioxide and water takes place. Now here this is benzene, that is C6H6. When it is burned in air, burns with sooty flame or smoky flame. Then here 15/2 oxygen molecules, that is O2 molecules, are used to form 6 molecules of carbon dioxide and 3 molecules of water. This benzene, when burned in air, it burns with sooty or smoky flame. Here we have completed all the chemical properties of benzene. Thank you.